Hi students, our lecture today is to deduce graph of the derivative given the graph of f of x. This is the main objective. Let us start by the relation between the graph of y equal f of x and the graph of y equal f prime of x. The relation is, in the graph of y equal f of x, you take the variation, you draw the table of variation, and you translate it into table of sign in the graph of derivative. Then, when you finish, you do the concavity, table of concavity in the graph of y equal f of x, and you translate it into variation in y equal f prime of x. We are going to note two important things, that the max and min in the graph y equal to f of x are the x-intercept in y equal f prime of x. We're going to see how. And the inflection points in graph y equal to f of x will be maximum or minimum in graph y equal f prime of x. So let us start. You have a graph of f of x. Here you have the roots d, e, and f. You have a maximum b and c, and you have an inflection point at the point A. Our aim is to deduce the graph of f prime of x. The first things we said, step one, variation in a graph y equal f of x is sign. So the variation is sign. So let us draw first of all the variation. As you can see, the function is increasing till minus 0.22, decreasing till x here 1.55, then increasing. So up, down, up. So if you see here, up, down, and up. So this variation of the graph of y equal f of x will be the sign. Up, it means positive. So here it will be root. We said that max and min will be root, so 0. This is a minimum will be what? 0. Decreasing, it means minus, then increasing. So the sign will be plus 0 minus 0 plus, and you have two roots, minus 0.22 and 1.55. So these are the roots. So if we go now here, let us do the scratch of this curve. So this is the function f of x. This is y, the y. The y, we have a root at minus 0.22. So here, somewhere here. And I have a root at 1.55. Suppose this is the root here. I have two roots. So if I go up, so what do I have? The function is positive from minus infinity till minus 0.22, then negative, then positive. So first of all, the function must be, as we said, positive. So it must be positive. It's coming from up, positive, it means. Then the root, we have then negative all till that root, then what? It is like a parabola. Positive sign, root minus positive. So let us repeat it. Positive sign, negative, then positive. So it has that form. Positive, negative, positive. So the second step we have, the concavity is variation. So let us go back to the curve. In concavity here, as you can see, we have negative, then positive, and I have inflection point at the point A and at 0.67. So the table will be minus, you have at x minus 0 at 0.67, then positive. This is the concavity. So I'm going to repeat it. Negative concavity, 0.67 inflection point, which is 0, then positive. So let us go to the graph. As you can see what I said, minus concavity 0.67, then positive. This concavity must be variation. What does it mean minus? In decreasing. And you have f of 0.67. It's unknown. We cannot know. You can put wherever you want. Then positive. So we said now we have, when we graphed up the sign, we said it has this shape. So you can see it has that shape. But we have at the point x 0.67, at the point 0.67, I have a minimum. So if I go back to the graph up, so here the minimum must be here at x minus 0.67. So here x is minus 0.67. And concerning elevation, you can do anywhere you want. You can have a curve of that form. Sorry, it must be a parabola. The most important to pass by these 2 points. You can have any other curve the way you want. For example, from here going down, then going up, passing by that point and up. So any curve of that form. So if you want to see a more precise one, this is the compare between the two. Let me erase these. So the green was the function given before, as you can see. The red is the derivative of the function f prime of x. So what do you realize? This inflection point here at A, all right? So sorry, at A, it must be what? It is an extremum in the second one. The max and the min here are what? Are the roots. So there is a mistake here. The dot point that I did here must start from A, not from E. It was a mistake. I'm very sorry about. So from A and down. So as you can see, this is a curve. You can have another one, whatever you want. So this is how we can deduce the graph of f prime of x given f of x. Let us take another example. So here it's another curve. You have 2 vertical asymptote, 1 horizontal. So we said the variation is this sign. So if you look at the variation, increasing, increasing, decreasing, decreasing, then increasing. So up, you have vertical asymptote, up, down, down, up at the point D. So we have one minimum. So you can see up, up, down, down, up. This is the point D. It will be the sign. Up means positive, then positive, minus, minus, positive. So now if you want to graph for instance, this function, we have first of all -4 vertical asymptote. We have 1 vertical asymptote. We have root at the point 0, and we have a root at the point 2.67. Before -4, the curve must be positive. It must be upward. Then upward here between -4 and 0. Okay. Then downward between 0 and 1 because negative, then negative between on that side, then you must have it what? Positive. So if you want to sketch it, to try to sketch it here, I will try to do it a perfect line. So here what do we have? We have at -4, 4 or -4, let me repeat, we have at -4, we have what is called a vertical asymptote. Let me put by red the vertical asymptote. You can, so this is the vertical asymptote at -4. We have one at 1. This is another vertical asymptote. So we said that, first of all, if you remember, it must be positive before -4. So we cannot take it down. So somewhere it must be like this. We must have here any asymptote. You can do it like this, whatever. It must be of that form. Everything is positive. Then positive, you have the root at 0, and then going negative. So it must be from up, going to 0, then where? Down. And then we must have it from down till up. Okay? So if you can see, it must have that form. So step 2, concavity is variation. I think that the time is over, so we're going to continue in this example in another video. We're going to continue in part 2.